Today we're going to be talking about 4.4 linear transformations, and we're going to start first with our vocab. A transformation is just the movement of a line or shape on a coordinate plane. And for this lesson, we are going to be focusing strictly on lines, but when you talked about transformations in middle school, you actually saw all sorts of shapes. Now, we have different types of transformations. The first is a translation. This is when we shift a line, and it can be up, down, left, or right. These movements will never change the slope of the line. The slope of the line is always going to stay the same. It's just that the line itself moves up, down, left, or right. A reflection is basically like we're flipping a line over another line, which we typically use an axis, an X or Y axis. This will change the slope of the line because if I flip it over the X or Y axis, it will actually change my positive slope to negative and my negative slope to positive. A stretch and compression. These two together, in middle school, you learned them as dilations. And if you remember, a dilation is whenever something gets bigger or smaller. Well, when we're talking about linear transformations and linear stretches and compressions, what this is actually meaning is to extend the line or make it longer. And if I'm talking about compressing it, I'm talking about shrinking it or making it shorter. When I stretch and compress a line, it is also going to change my slope. So really the only one where my slope isn't affected at all is a translation. So now we're going to take some time to dive deeper into each type of transformation, and we're going to start first with a vertical translation. So vertical translation just basically means I'm moving up or down, and you can see that right here, up or down along my coordinate plane. Now, to get a full understanding of this, you can easily go into Desmos and you can graph this problem. Now, in order to do that, the first thing you're going to do is you're going to type your original function. In this case, my original function, it tells me is f of x equals x. So I'm going to type that on one line. On my second line, I'm going to type in g of x equals to f of x plus 2. So what this is basically saying is my new function equals to my original function plus 2. Now, if you graph these on Desmos, you'll be able to see that my line is shifting up 2. That's what this plus 2 means. And so what this does is it shifts every single point on the line up 2. So if I want to graph my new line, I could just take each point and shift it up 2. And I'm going to draw my line through there and add my arrows on each end. All right, so again, to see the second example, I could go back into Desmos. Again, I'm going to type my original function, which is f of x equals to x. That is the line you see on the given graph. And then it says, let the new function equal to the original function minus 3. This minus 3 is going to be shifting down 3, which means every single point on the original line shifts down 3. So then I can plot all of those points and see my new function. Again, connect all of my points with the line, and don't forget to add arrows to each end. So in both of these, my original function is my black line, that's my f of x, and my new function is my colored line, which is my g of x. So ultimately what this means is anytime I see plus a number in the very back of my equation, that's going to be shifting up that many units. And anytime I see minus a number in the very back of my equation, that's going to be shifting down that many units. All right, the next type of transformation are horizontal translations. Now, you'll notice the difference of this is we have plus or minus a number, but this time it's inside of the parentheses, whereas before we had plus or minus a number behind the parentheses. Whenever you see it inside the parentheses, this is shifting left and right. Now, this gets a little bit confusing. If I went into Desmos, again, I'm going to take my original function and say my original function is f of x equals x. I'm going to type that on line 1. And then I'm going to type my new function, my g of x function, and say that it is equal to f of x minus 2. And if I plug this into Desmos, I'm actually going to see that this line is shifting to the right 2, which is opposite what our brains would normally tell us, because when we normally see minus 2, we think it either moves down or to the left. But whenever it's inside the parentheses, this is actually going to be shifting to the right. It's actually moving the opposite direction than what we think. And you can kind of relate this to what you saw happen in your point slope form. When it was in parentheses like that, it was opposite the direction you thought. So each point shifts right 2, so I can plot all of those points. And this is the graph you would see in Desmos. Again, you would connect the points with a line and add arrows to each end. My original function is that black line, and my new g of function is the pink. Let's look at another one. Again, I'm going to use f of x equals x as my original function, which is represented by that black line given on my graph. My new function, it says, is equal to f of x plus 4. Now, if you think about it, when it said minus 2, it moved to the right. So plus 4, I bet you can guess, moves to the left, and it moves 4 units left. So if I do that to each point, you will see your new line take shape. And this is what you would see in Desmos. Again, similar to that point slope, when it's inside those parentheses, it's moving opposite the direction that we think. So my original function is the black one, and my new function is the green one. And you can see that it shifted left 4. All of these translations, you notice that the slope of the line did not change at all. It was just basically my y-intercept that changed. All right, the next type of transformation we're going to talk about are reflections. And remember, reflections typically happen across an x or y axis. So we have to be able to distinguish when is it across the x and when is it across the y. So for these, it's a little bit harder to see these reflections if I use f of x equals x. So instead, on this one, I'm actually going to use my original function as f of x equals to 2x plus 1. So if I go into Desmos and I type in that original function, f of x equals to 2x plus 1, it would give me the graph in black that you see on the picture below. Then I could type in on the second line, g of x equals to f of negative x. This is going to show you a line that is actually a reflection, but it's going to be a reflection over your y-axis. And what this means is that every point is mirrored across this y-axis right here. So that means it's going to keep the same point right there, but instead of being 1 unit to the right, I'm going 1 unit to the left. Instead of this point being 2 units to the right, it's going to be 2 units to the left. And you can see how it looks like a mirror image that's flipped over that y-axis. Same as the ones below. If I would be 1 to the left, I'm going to go 1 to the right. This one would be 2 to the left, so I'm going to go 2 to the right. And this would be 1, 2, 3 to the left, so I'm going to go 3 to the right. Again, I'm going to connect all of those points with my line, and I'm going to add arrows on each end. Now, look at the second problem. Again, I'm using the same original function of 2x plus 1, but this time you'll notice that my negative is out in front of the f. This is going to be a reflection over the x-axis. So that's going to mirror all of my images, but this time I'm going to be flipping it up and down instead of left and right. So my point right here is 1 unit above the axis, so now I'm going to go 1 unit below the axis. This one is 1, 2, 3 above, so then I'm going to go 3 below. This one is 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5 and plot a point. Same thing on the other side. Instead of going down 1, I'm going up 1. Plot a point. Instead of going down 1, 2, 3, I'm going up 1, 2, 3, plot a point. And then last one, instead of going down 1, 2, 3, 4, 5, I'm going up 5, plot a point. And this time you can see that all of my points are mirrored up and down across that x-axis. Again, connect my points and draw arrows on each end. So if I'm reflecting across the y-axis, my negative sign is going to appear inside the parentheses in front of the x, which is kind of like a negative slope, but inside the parentheses. If it's reflecting over the x-axis, it's going to be like a negative slope, but out in front of the f. All right, the next type of transformation we're going to talk about are my stretches and compressions, which is going to be telling us if my line's getting steeper or less steep. So with that said, I'm going to first focus on, so if I see a number that appears in front of my x, that is going to tell me that it's either a stretch or compression, and that means my line's getting steeper or less steep. So I'm going to start first with focusing on the vertical changes. This is when I will have numbers in front of my f of x. So this is out in front of the f, okay? Now, if your number is greater than 1, your graph is showing a stretch. If your number is between 0 and 1, then I'm showing a compression. So again, just like before, the best way to see these is by plugging them in Desmos and seeing the reaction. So I'm going to use my original function again as f of x equals to 2x plus 1. And that is what's given on my graph so that I can see the change a little bit more clearly. Now you'll see I have a 1/2 here that appears in front of the f. This is my new function, is half as big as my original. So what this is telling me is that not only is my slope going to change, but so is my y-intercept, okay? Now, this, because it appears in front of my f, it is a vertical change. Because it is 1/2, which is between 0 and 1, it is a compression. Now, if I look at this on a graph on Desmos, okay, you're going to see that my slope cuts in half and my y-intercept cuts in half. So if my original y-intercept's at a positive 1, my new y-intercept is going to be at 1/2. Then my slope is also going to change. My original slope is positive 2. So half of that is going to be a slope of positive 1. So that means up 1 and right 1. Up 1 and right 1 over and over again. Again, you can see this change a little bit better probably on Desmos But you can then notice that my line is actually getting less steep here. Connect and draw your arrows. So when we're looking at this, we are looking for, it's a vertical compression that is less steep. All right, so let's look at the second one. You'll notice the change here. It still appears in front of the F, but this time the number is bigger than 1. So it's still going to be a vertical change because it appears in front of the F, but since it's bigger than 1, it is now a stretch, which remember it means it's getting longer. Okay, so this is saying that my slope and my y-intercept are both being multiplied by 3. So if my original function, remember, is 2x plus 1, and that's what I see on my graph, my original y-intercept was 1, my new y-intercept is going to be 3 times that. So my new y-intercept is going to be at positive 3. Then my slope, my original slope was 2. My new slope is going to be 3 times that, so it's going to be 6. Well, if I go up 6 and to the right, it's going to be off my graph. So I'm going to go down 6 and to the left. Then I can connect my points and I can draw my arrows on each end. And you can see that this graph, if I was climbing this line, it is much steeper than the original line. So if my number is in front of the F and it's bigger than 1, it's going to be a vertical stretch that gets steeper. All right, now we're going to talk about the horizontal changes. And so here I'm going to be looking for a number that's going to appear in front of the X only. So it will not be in front of the F, but in front of the X. In this case, if your number is greater than 1, it's actually going to be a horizontal compression. And if it's between 0 and 1, it's going to be a horizontal stretch. So let's look at these examples. Again, we're going to be using our original function as the 2x plus 1. In this example, on the very first one, it has the 1/3 in front of my x, but notice it's kind of sandwiched between the f and the x, all right? This is going to be saying that only my slope is changing by 1/3, not my y-intercept. My y-intercept is actually staying the same. So because it is in front of my x, it is a horizontal change. And because it's between 0 and 1, it is a stretch. So I told you my original function was 2x plus 1. My y-intercept is not going to change. So I'm going to still have a y-intercept of plus 1. But now instead of a slope of 2, my new slope is going to be 1/3 that. So it's going to be 2/3. So I rise 2 and run 3. Again, you can see this a little bit easier if you don't understand it right off the top of your head by using Desmos to be able to see that change. Okay, I connect my points and I draw my arrows. You can see in this instance that my line is getting less steep. All right, and last example like this, I have a number in front of my x, but it's sandwiched between the f and the x. This is going to be a horizontal change. And because it is bigger than 1, it is a horizontal compression. Again, the y-intercept is not changing from my original function, but my slope is. So I'm still going to have a y-intercept of 1, but now instead of my slope of 2, I'm going to have a slope 5 times that, which is 10. Well, this is going to be way off my graph, both if I go up 10 and right 1, or if I go down 10 and left 1. So I'm going to give you a rough estimate as to what this line would look like. And don't forget to add your arrows to both ends. And you can see that this line is definitely getting steeper. So one connection I want you to draw is no matter where the number is, if the number is between 0 and 1, it's getting less steep every time. If the number is greater than 1, it is getting steeper every time. The only part that changes is whether it's a horizontal stretch, horizontal compression, or vertical stretch and compression. Now, something that can help with the stretch or compression if you don't want to straight memorize it is you can think about, once you know that it's horizontal, I can highlight that horizontal axis. If you notice, if I start at my black line and I move to my new line, my blue line, I'm getting closer to the highlighted axis. Closer to would be a stretch. Look at example number 2. Again, I know it's a horizontal change because it's sandwiched between F and X. And if I start at my black line and move to my new red line, it is moving farther away from my highlighted axis. Farther away would be a compression. So you may be asking yourself, what are you going to have to do with this? And the idea is, if we give you an original function and a new function and just equations, you are able to tell us, how is that graph going to change, or how is that line going to change on the graph? You could be able to describe the changes without physically seeing it. Now, could you technically graph it in Desmos and look at the changes? Yes, but the idea is you don't want to have to rely on that. So let's do some practice of what you're going to be expected to do on both your homework and your quizzes and tests. Now it says determine the transformation on the graph of the function below for each of the following. It gives me my original function right here. This is extra information. We actually can completely ignore it. We don't need it in order to answer the question. I am strictly focused on what the changes on the new function. So on question number 1, I'm going to be looking for anything that's not a G, F, or X. So I see that there is a negative sign. So I have to then name it. Remember, if I see a negative sign in front of my X, this is a reflection of some sort. So I'm going to say a reflection. Since it is in front of the F, it is over the X-axis. And you do have to have that memorized, that in front of the F is over the X, and sandwiched between the F and the X, it would be over the Y. All right, number 2, again, I'm looking for anything that's not a G, F, or X, so I see this plus 4. Anything that appears behind the X is going to be a translation, so that means it's a shift up, down, left, or right. Since it's behind the parentheses, that is up or down, and it moves exactly the direction you think. Since it's plus, it is moving up 4. All right, number 3, again, focus on anything that's not a G, F, or X. I see a 2. This appears in front of the X, so this is a dead giveaway that it is my horizontal vertical stretch compression. Since it is sandwiched between the F and the X, I know it's going to be a horizontal change. And since the number is greater than 1, I know that my line is going to be getting steeper every time. So I want you to think about this. I can make a little rough sketch out here to the side. I'm talking about my horizontal axis, so I highlighted it. If my original line, I'm just going to draw my original line. Let's say it looks like this. And if my new line is getting steeper, you can tell it's moving away from the highlighted axis. That makes this a compression. Number 4. Now on this one, I actually see 2 changes happening. And this is the most common mistake that students make, is they group the negative and the 0.3 into one change, and that is not accurate. The negative is one change and the 0.3 is a different change. So if I'm looking at just the negative sign first, since it's in between the F and the X, this is a reflection. And since it's again sandwiched between two of them, it's over the y-axis. Now the 0.3, since it's sandwiched between the F and the X, I know it is a horizontal change. And since it's less than 1, it's between 0 and 1, this is an example of less steep. Well, again, I can make like a rough little picture. My horizontal axis is right here. If my original line, I'm just going to draw an original line, and my new line is less steep, you can tell my line is moving closer to that axis. That has to be a stretch. If that gets confusing, you can just memorize a horizontal stretch and less steep. All right, number 5. I see a 3. It is in front of my f of x, so that means it is a vertical change. It is greater than 1, so this is getting steeper. If I think about my line, I'm talking about vertical, so that's this up and down axis. If my original line looks like this, and my new line is getting steeper, you can see I'm moving closer to that axis. That is a stretch. All right, number 6, I can see actually 2 changes. I see a -2, but I also see a +6. Both appear behind the X. So this is a dead giveaway of when I have shifts up, down, left, and right. The first one I come to is the -2. It's inside parentheses, so this means it's shifting left or right. It goes opposite the direction we think since it's inside those parentheses, so it's moving right 2. And then the +6 is outside the parentheses, so that's a shift up or down. Since it's positive, it's moving up. So up 6. We have a couple more examples. All right, number 7, I see 2 changes happening. The first is my negative, and the second is my 2. Remember, those do not go together. So the first, my negative, since it's sandwiched between the F and the X, this tells me it is a reflection over the y-axis. The 2, since it's in between the F and the X, it tells me it's a horizontal change. Since it's greater than 1, it is getting steeper. I can envision my little graph. I'm going to highlight that horizontal axis. If my original function is my blue line, and I have a steeper line, you can see that my new line is moving away from my horizontal axis. So that makes this a compression. Number 8, on this one, I actually see 3 changes. I have a negative, I have a 5, and I have a +4. So let's start first with that negative. It's in front of the f of x, so that tells me it is a reflection over the x-axis. The 5, since it's in front of the f, tells me it's a vertical change. Since it's greater than 1, it is getting steeper. So if I draw my little rough sketch of my picture, I'm looking at the vertical axis. If my original line, I'm going to make this one red. and my new line is getting steeper, you can see that my new line is moving closer to my axis. And remember, closer is a stretch. All right, number 9. I see one change. It's a negative sign in between the F and the X. So this is a reflection, and it is over the y-axis. And number 10, I have a lot of things happening. I have a negative, I have a 3, I have a +1, and I have a +2. So let's go through each of those. The negative out in the front, since it's in front of the F, is a reflection over the x-axis. The 3, since it's in front of the F, is a vertical change. Since it is greater than 1, it is getting steeper. If I draw and I highlight my vertical axis, let's say my original line is my blue line, my new line is getting steeper. We can see that my new line is moving towards that axis. Closer to or towards is a stretch. The +1 is behind the X. So remember, anything behind the X is a shift up, down, left, right. Since it's inside parentheses, it's going to move opposite the direction we think, and this is going to be moving left 1. And then last one, the +2 in the very back, is shifting up or down. Since it's a +2, I'm moving up 2. So the very last part of this, I'm just going to summarize all of my rules for you. The first, if I have a number in the very back of my X outside the parentheses, that's going to be a shift up or down. Positive means up, negative means down. If I have a plus or minus behind the X, but this time it's inside the parentheses, this is going to be shift left or right, and it moves opposite the direction we think. So plus would be moving left, and minus would be moving right. If I have a negative sign in front of the X at all, this is going to be an example of a reflection. In front of the F is a reflection over your x-axis, and sandwiched between is going to be a reflection over your y-axis. And then last are my vertical stretches and compressions. And these are any number that appears in front of my X, not looking at the sign. So if it's in front of my F, it is a vertical stretch or compression. If it's in between my F and my X, it is horizontal. Remember, no matter where it is, if it's greater than 1, it is always getting steeper. And if it's between 0 and 1, it is less steep. Now in Canvas, you should see this doc that kind of summarizes everything up for you to help you study that anything that appears in front of the X has to be a reflection or a vertical horizontal stretch compression, and anything that appears behind the X has to be a shift up, down, left, right.